right, gonna start stuff off. So, hello everyone. Quick intro. I'm Ryan. I'm the tech lead for AWS Security Outreach. We're the team responsible for coordinated vulnerability disclosure at AWS. And I've got a bunch of accolades. They're not really relevant. So if you care to communicate, just hit me up. The QR code goes to my LinkedIn, or I'm on like the cloud security forums if you want to chat. So I'm really excited because one of the things that I'm very, very always interested in is improving my quality of life. It's really selfish, but the main thing about it is if you're doing repeated stuff over and over and over again, it gets tiresome and it's hard to scale people up to do it. So with the new CNA directives that came about in 2024, I wanted to find a way to scale this. So because of this, what we want to do is we want to take a lot of the basic things that we have to teach our analysts to do over and over and over again, and requires a certain amount of time to train them. So let's jump on into it. So to clarify, the Git repo itself is called Chatbot to help security teams perform vulnerability assessments because it gets branded by a lawyer. So what most people are calling it is, well, we called it CNA-GURU as a nickname. Thanks to Chris Ferris, now I'm calling it Chat CVE because he's better at naming things. And yeah, call out to Chris. So why did we build the assistants? Well, scoring vulnerabilities is hard, and training humans is harder. So if this is a really like niche skill set, why would we even build something like this? Well, like we said, at VulnCon last year, we were talking about all the new rules that came about. And one of the things with those new rules is it's requiring more companies and software builders to do CNA type work that they did not previously do, wasn't part of their training, wasn't part of their education or their skill sets. So what we want to do is try and lower the bar to entry for people and allow them to kind of punch above their weight class. So last year, we had a couple of these sessions. We're talking about the new rules. I complained loudly about trying to translate and train engineers to do stuff. And a bunch of people came over to talk about it. Sarah Evans, Casimir Schultz, Christian Sievert, all these guys, we all sat at the same table, and we had a kind of a common complaint, and after about an hour, we brainstormed a little bit, threw our complaints back and forth, and this is what came out of that. I went home that night and I started building because I build, I don't really learn. So how did we build this? Well, the first thing that we did is try to figure out how to put together infrastructure to do this, right? Infrastructure is expensive, it's complicated, you have to worry about reliability and all these other things. Well, my first version of this was like the island of misfit toys. I went up to the AWS Labs examples and I looked at all the CDK in Python that had to interact with chatbots and stuff. And I was able to grab some interesting examples that existed previously, and it allowed me to build my desired user experience. What would this be useful to do? We needed something portable that people could run in different places, easy to deploy, right? We want it to be almost natural language processing, though that's way fancier than what we're actually doing. But we want somebody to be able to enter in a vulnerability description in words that they would actually use to talk to people and be able to work off of that. Then what it would do is it would take that data and use a customized prompt that allows it to search our knowledge base with context. And then lastly, what it does is it uses that context from the knowledge base and the user inputted information to match data. So that's how we're doing the linking between the natural English language stuff and what is in the knowledge database. So the knowledge database itself is built off of all the data that you get from the first website on CVDs, CWEs, all that guidance stuff, that's all public. That's the only stuff that was used for this. So all of you can repeat this. It's all free and public. So let's talk about that actual infrastructure that we're building. This cool diagram, I didn't actually have to build because it already existed in an existing project. This was taken from another project from AWS Labs that was about creating images with Bedrock. And there was a second project that allowed us to do agent retrieval, which is how I thought I wanted to do this the first way. Foreshadowing. So the chatbot itself was built just interacting with Amazon Bedrock. The front end of it is Streamlit, which is an open source chat thing. All of you can use it. It's free online. To actually host stuff, we're using the ECS, so container services, Docker in the cloud kind of thing. And we're using AWS Fargate to do it because of when I built this, certain features were required for the ECS. So we chose to use Fargate for that. Now, this looks big and complex, and that's one of the reasons that we're going to talk about the next milestones in the project. So going up to here, some of the key features that we're going to be talking about that work with this. What you're looking at is the Streamlit output. So this is that fun little chatbot front end. One of my favorite things about this is the amount of time it takes away from repetitive training. All right, who here has ever had to train someone to score a CVE? Yeah, all right. And how long did that take? Yeah, way too long. So long. Like I didn't have any gray hair when I started training them, and now I'm bald. So one of the problems with that is follow-up and context questions, right? Everyone can make a list, a run book, a thing of set questions for people to follow in a straight path. But the more you work with vulnerabilities, the more you realize everyone's a unique snowflake of them, and they're all going to be different in different ways, and always something's going to be different. How do you react to the changing context as you go through your normal workflow? Well, you do that with follow-up questions, so contextual follow-up questions. It's the same way that you would work with your mentor trying to learn this. They say, how to do steps 1, 2, 3, but you don't understand how 2 and 3 connect. So you ask a follow-up question, you ask for context, you ask for further explanation. And that's what I wanted to build into the assistant, right? This is not a replacement for humans. This is about offering assistance and help to people and getting them to the answers that they need to make educated decisions faster. So we're trying to empower the human with this, not replace them. So one of the questions that we see here is, we asked it to calculate a CWE and a CVSS score. Well, we didn't agree with what CWE it decided for determination. We were able to ask it a follow-up question. Why did you choose this CWE over another one? And it was a very simple, straightforward answer. It's because the text that was entered by the human had certain phrases that mapped to that CWE. Now, why did this one come up versus the one that the human that evaluated this chose? Well, we're going to go into that with some of our metrics in a bit, but other talks about LLMs said this today. Oh, not today, this week. LLMs tend to go lower down on the parent lineage for CWEs. Humans tend to go higher up in that umbrella because it's encompassing, where the AI stuff tends to go to that umbrella and then go down a few steps. So that's sometimes good and sometimes bad. And we'll talk about that in a minute. So next up, in this example, we wanted a general knowledge question. So once again, this is training for analysts, not people that know what they're doing. Though this is helpful for me too, because I don't really know what I'm doing. So sometimes I have dumb questions, like I forgot what a certain vector string in a CVSS score is. Explain it to me. Why do I care about this? Why is it network versus local versus whatever? All right. So in this case, we're asking some basic questions like, what is a CWE? And we get an answer. Then we can ask a follow-up question, or we can submit a vulnerability description now that we remember what a CWE is and get it to be scored and calculated. I love the feature personally, because I have to answer this a lot when I train people. So it's very nice where I don't have to repeat myself of like the basic things over and over. Everybody has a wiki page with a bunch of definitions of different things and explanations of their common tools. I don't have to copy and paste, go read this, right? You can just ask the assistant your question as you feel it. And because of that, we've noticed that analysts are less skittish about asking questions to their like tech leads and stuff, because now they can ask what they believe is a dumb question to the AI bot and ask it to give them some context, and then it allows them to build a better question because now they understand more context about it, and they start to understand this is the gap. What they start to understand, they know what they don't know, kind of thing. And using this as part of the training is helpful. So, evaluation and accuracy. This is a huge debate, for LLM accuracy, right? We all know that that AI hallucinates, right? How do we deal with that? Well, in fairness, most engineers I work with hallucinate. So really, we're using the same kind of guardrails, right? We don't let this AI drink during work hours. And we also make sure we give it guidelines for what it can and can't do. And that's part of the custom prompt that we work with. But some of the accuracy stuff. So the engagement time went down, right? That I think is one of the most important things. The ROI highlights. So when I say 3 hours to analyze, that's a trained, like I've signed off that they know how to Google what a CWE is, kind of stuff. And I feel that they can score things on their own. Takes them roughly 3 hours to go from here's a vulnerability description to scoring, CWE determination, a small write-up, justification, basically building out all the information for either a CVE submission or a GHSA submission. With the tool, they were able to take the 3 hours and cut it down to just a few minutes because they were able to ask the same questions. And then I'll show you some of the other cool features that we use to help them build their responses and write-ups in the first draft of them to allow the human to edit. Because I don't know about you, but staring at a blank page and going, shit, I need to describe a vulnerability is like, it's a large jump, right? It's that barrier to entry that kind of scares people. This is lowering that barrier to entry. Another thing that people thought was pretty cool was the actual accuracy we got out of it. This is a small sample size of only 300 vulnerabilities. I know there's more than 300. So I only afforded time to do 300 for checking because I paid for this. So if you guys got credit cards, let me know. We'll start scanning. But we got roughly 90% accuracy for the 300 randomly chosen CVEs. We went to the NVD database, and those fun people that I mentioned earlier, we sat at a table last year and they gave me two numbers. The first number was what random page of NVD results to go to, and the second number was which CVE on the page to grab. And we grabbed 300 that way and threw them through, and they all were scored within 0.2 on CVSS scoring, and it gives three options for CWE, and the CWE mentioned on the NVD page matched about 90% of the time as well. And when it didn't match, the majority of the time it was using a CWE that was lower down in the lineage, so a more niche, narrow scoped one. There were some that were just blatantly wrong, right? But one of the reasons for that was the verbiage that's used in the vulnerability description. It was very poor verbiage. I won't name the vendor, they're huge, but they use very generic language, which doesn't really help to tell you what the vulnerability is. And because of that, it didn't score it as severe as it actually was. When we went and looked at the CVE, it was a little more vicious. So that's why the score on NVD matched and made sense. But I wanted to bring those up because you're going to see, your mileage may vary. And also we do a little bit of tuning to our prompt for contextual things. Like I have a different scope and a different risk surface than you guys do, right? So you are going to have to do a little bit of fine tuning once you start putting your vulnerabilities and stuff through it to make sure it answers questions from your perspective, not mine. So evolution. I started talking about this a little bit because I wanted to show off the infrastructure of the first thing we built. The first time we built it, it was that huge infrastructure because I used pre-existing stuff just to get the basics out there and then work on the prompt, the knowledge base, and the things that would give me the relevant answers. Well, that was great. It was really accurate at the time. It was fast, but it was expensive. I thought it was pretty cheap when I was developing it. And then I opened it up to a team of 10 people for a month. and was asked to shut it off. So um, we found a lot of value in the tool, but not enough to justify the cost, which is a common problem we have. You got a great tool, but you can't afford it. So what did we do? We created CNA-GURU Junior. This is a stripped down version. Instead of using the knowledge base, which in AWS using Bedrock knowledge base, you use knowledge base agents. There's an open search index. There's the knowledge base itself. There's the S3 bucket storage cost. It adds up. So we stripped a lot of that out, and we decided that if we can choose a model to use that is trained on the NVD data, we can use like a local RAG system or something like that to input our custom knowledge and then use the same prompt. So that's what we did for CNA-GURU Junior, and it ended up reducing costs significantly. But as we were trying to onboard more teams to this, we ran into some issues, namely onboarding. How many of you know what CDK is? Exactly. Yeah, I know you work there. So no one raised their hand for those in line. That's not unsurprising. CDK is AWS's like infrastructure as code language, basically. It's like a middle layer that allows you to define what your infrastructure looks like, how to configure it, all that stuff. And then like you put your infrastructure as code and version control, and you can export whatever. That sounds really complicated, right? It's actually not complicated to do, but realistically reading it, it sounds overwhelming. And a lot of people weren't willing to learn how to deploy via CDK to get this infrastructure. So how do we overcome that hurdle? Well, that's where I wrote CNA-GURU Esquire. This is CNA-GURU Junior, but it runs inside a Jupyter notebook. So that way, it's super portable. You don't need to build extra infrastructure, but it still uses the same local RAG and prompt and the same model as CNA-GURU Junior. So it gets very similar results and it's similar pricing. Next up, let's talk about some of the evolutions. So I'm going to bring you guys through a bunch of examples pretty quickly. We might speed run them, but the main thing is I'm showing off different kinds of questions you can ask it and what type of responses you get. Here, we're specifically looking at the simplistic questions that we can ask. So this is our prompt. It gives you some basic descriptions and definitions at the top. That is an example that you can submit into there. I've run it like 100 times. It usually gives the perfect CVS and CWE scores, so you can use it to test. But your basic question: what's a CVE? All that kind of fun stuff. But then in CNA-GURU Esquire, what we're able to do with this is by running it in the Jupyter notebook, we actually created a chatbot experience. So that way, when you ask your follow-up questions, it's still contextualized. So the AI keeps context of your entire conversation, and that's going to be important in a minute. So the benefits and use cases. We talked about the training, right? One of the other cool things is scalability. Everyone says serverless, awesome sauce. Hi, person taking picture. So scalability matters. You might be a small shop. You can stand up one or two instances. I work at AWS. We are ginormous, right? In order to run this, I have a fleet of systems in order to run that many concurrent queries and stuff for people, because not only do we use this for manual input, but we also do some automation that I'll talk about. What's really great about this is the flexibility. So we talk about customer choice as like a company tenant and stuff like that. But in reality, I care more about how easy it is for you to use, right? Like, I want you to be able to pick this up, drop it on your computer, load it up, and start kicking off with it. I want you to be able to fork this, and with the documentation in the GitHub, understand how the components work so you can modify it for your needs. Like, I want this to be a foundation for folks. So that's what I kind of find as some of the benefits, the flexibility, the extensibility of it. It's open source, it's flexible, you can plug in. So some of the common use cases that we get with this: security advisory creation. So how do we draft up a CVE or a GHSA? Analyst training support. That's what I harped on in the beginning, because that's my main use case. I have a bunch of analysts I have to train, and whether or not they're on a rotating clock through attrition, I still have to keep training people over and over and over again. This helps save me time there. And then quality assurance. I've been doing this for a lot of years. I still am terrible at it. So I want to validate things. I want a second opinion. I want to validate what I said was right. So next up, use case CNA related general knowledge. So this is inside CNA-GURU. It's really hard to do screenshots on something this size, but suffice to say, this is general knowledge questions up top. And then down here, I ask for a CVS vector string for the vulnerability description. It gives me the scoring and it starts to answer some information for me. But let's move on to what it actually shows. So we build on the general knowledge. And in this, we ask the assistant to calculate that CVSS score. And also, it gives us the vector string. It gives us a quote from the string of data that the user inputted, and it gives us a quote from the knowledge base. So I don't have to convince you that these two things match. This is a quote from both what the human inputted and was taken out of the knowledge base. If you can't one-to-one that, learn to read. You heard me. Next up, the CWE portion, determining a CWE. Well, trying to do it the first time or just trying to get one, really hard. I started this off with giving 10 as a result for the user to choose from. We cut it to 3 because options are hard. So now this gives the top, what it considers to be the 3 most relevant or related based on the description. Next up, creating a CVE. This is cool because remember, it's contextual. You asked it a bunch of questions, you asked it to score a description, you asked it for a CWE. You can use that information because it's already remembered to say, can you draft a CVE for me? It might be able to give you enough info, but a lot of the times it'll say, you don't have enough information to write the draft. These are the attributes you're missing. So it helps you write and draft your CVE by giving it more information so it has enough to do it. Same thing with the GHSAs. You're able to use it contextually to grab the info that already was there, and then you're able to ask it, what am I missing? What should I improve? What kind of guidance can I have for this? And this right here is actually the write-up from this session. So all the questions that I asked so far in all the slides, this is the culmination of it. I asked it to generate a GHSA draft out of all that info, and it wrote it up for me. References, CWEs, mitigation steps, impact, all that, because I gave it all the information from in the conversation up to that point. So super cool, fast example, speed run. Next up, open sourcing. Why did we open source this? Well, 2 reasons. One, it's not really all my work, right? I was at VonCon last year. I'm not the only person that had this complaint. I sat down with a bunch of people. We all had the same problem. We, drank and yelled about it, but I went home and I wrote something about it. But I didn't leave it at that. I came back to VonCon the next day and I asked people for feedback and more the next day. And we did more examples the day after that. So in those 4 days, we actually did a lot of iterative testing and updates to it to get to the point where we're able to get some usable information out of it. And the second reason is sharing is caring, right? I know this was a problem for me. I use a modified version of this in production, right? Not the exact one because we can't issue that out, but I use this, our modified one. You can use this too. Totally free, grab it, build, customize, right? This is not going to replace an analyst right out the bat, right? So in conclusion, I'd like to say that this represents a great step in assisting security advisory management, like the whole life cycle of it. All the resources, including the complete project, documentation, reference material, everything is at GitHub. That QR code goes to the link to the project page. In fact, there's a blog thing written on it that explains the process, and there's deploy instructions, examples of outputs, all kinds of stuff on there. And the last thing I really want to reiterate is this is not a solution to replace humans. No matter what you think or your boss says, right? The goal of the tool is to make it easier for humans to find the information they need to make informed decisions faster. The tool assists in making that information retrievable in a way that is natural to use to the user through the chat interface. That is the big benefit. You're not asking people to read a book. You're not asking them to Google stuff. You're asking them to have a conversation. And that lowers the bar to entry, especially for non-technical users, right? So I really look forward to how the community adopts this. You can always do PRs. You can fork it. If you want me to work on your fork, let me know. And as always, we'll take any questions, and super, super happy to talk with you guys. Thanks. And scene. Does anyone want to ask the kitty questions? It's too cute of a cat. Oh, do you need microphone or? Oh wow, you're way over there.
Hey, can I go?
I got you.
Yeah. What colors does it come in?
What colors?
Yeah.
All colors. One of the cool parts about the chat bot with Streamlight is that I can do fuchsia, rainbow, or salmon.
More seriously, I love the idea of lowering the psychological safety sort of barrier for newbie analysts. Is it currently possible to sort of have it in a group chat environment where you can sort of catch it saying silly things to your newbie analysts so that it's not the blind leading the blind?
So you control the target of output. Right now, the target of output and input is the Streamlight app, or in the Esquire version, it's in the Jupyter Notebook. However, you could do a Slack bot if you wanted to, and basically have like, or whatever chat thing you like, and basically have it work there. Because really what matters is the context, and when you start a new conversation with it, that's what matters, and how you're going to store your conversation. Outside of that, whatever front end or interaction you want, totally possible with it. Plug and play. Yes.
Can you hear me? Okay.
Yes.
Yes. Thank you, Ryan, for great conversation and presentation. And I have two questions, actually. The first one, when you talk about like better fine tuning, are you saying that we have to do post training, maybe with some reinforcement learning with the input from the user, or it's a better prompt engineering?
So actually both. So it depends where your problem is. So one of the cool things about this is it does use Amazon Bedrock, and Amazon Bedrock has a feature where you can record all the inputted prompts. So one of the cool things that I did is, because it's company property and we don't have to worry about privacy for our internal stuff, what's cool is I get to analyze all the prompts, and then I figure out what are common misconceptions from users, and I can give them some training to ask better questions. But also part of the iterative cycle that we did was tuning the prompt. The prompt is a generic security analyst right now that is meant to ask general questions, has a list of additional common questions and some data. But for your use case, you'll want to look through, like, when you're doing scoring, what are your most common questions and what are the most common outputs that you care about? Just tack that onto the prompt, and you'll be able to get that additional context out of it. And it'll require some tuning, but it's mostly prompt engineering at that point.
All right. So actually all the techniques works just well, right?
Yeah.
Thank you. And the last question, the second question, do you see that some models are better in this CWE composition over like maybe Llama or a Claude? Do you have some examples and suggestions which models better on this vulnerability matching? Thank you.
I can say officially some models are better than others. I can not officially say which ones, because as an employee, I can only use certain ones. So this was all built using Amazon approved LLM solutions internally. So this was Claude for this one.
I think we had some more questions in the room, but please try to catch up with Ryan after the talk, because we got to start getting the next folks in here. But really appreciate the time, Ryan.
Thank you so much, everyone. Cheers.